Hi, Miss Womack with more amplitude, period, vertical shift, phase shift, and we are graphing sine functions and cosine functions. So I hope you're getting faster at this. Again, our amplitude is going to be located in the A position, leading coefficient before sine 2. That's your amplitude. Your period is going to be 2 pi divided by B. And don't forget B, where's it at? And also don't forget that that's 3 halves. So 2 pi divided by 3 halves. 2 pi divided by 3 halves. Are you getting faster with the fractions? If not, practice makes perfect. Leave it, change it, flip it. Pretty good. 4 pi thirds. Bingo. There's our period. 4 pi thirds. Our vertical shift, well, there is none. How do I know that? Because there is no D, nothing outside of there. However, there is a shift. I see a negative sign here, so I know it is going to move to the right. So let's establish that. I know it's going to move to the right. I saw that minus sign. I know it's going to. Now let's figure out how far. So we're going to take the opposite of C, which is negative pi, so we're going to make that positive pi, divided by 3 halves. There it is again. Leave it, change it, flip it. Get used to it. 3 halves. Leave, change, flip. So that's going to be 2 pi thirds. All right. Now, never fear. We're going to help you out here. So count 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3 out here, and we're going to put our period, which is 4 thirds, or 4 pi thirds. 4 pi thirds it is. Now I need to split that in half, right? Well, it looks a little nasty, so let's turn it into 6s. I think it'll come in handy. So how did I do that? 3 times 2 is 6, so I'm going to do the same thing to the top. Now that is an equivalent fraction if I ever did see one. Split the 8 in half, a lot easier. That's right. This right here is going to be 4 pi 6. Split it in half again. That's right. Just the numerator. Are you getting used to it yet? 2 pi 6, 4 pi 6. What's this one going to be? Did you guess 6 pi 6? By George, I think she's got it. Or he's got it. Now, we won't convert them just yet. We'll just wait on that one because they may just be just fine the way they are. So, I've got a phase shift in thirds and I have 6s. So, maybe I wanted to see what this is. 2 pi thirds, or 2 thirds, is equal to multiply the top by, same thing as like 4 pi 6s. And I do see that down here. 4 pi 6. So my phase shift is going to the right that far. Pretty good to know. So if I can do this graph and just move all my points over the 2 purple marks, I'm good. You got it. So let's look at the parent function. We'll make this be 2, and this is going to be negative 2. I don't know if that's hard to see or not. Well, that's okay because we're going to do that. So the normally a sine curve would start here, go up here, and then go down there, and then hit down there, and then come back out right here. And we've graphed that a couple of times. But all of these dots have to move 1, 2 over. So I'm going to start with the right a little bit, and it's actually going to move off the graph. So let's back up to this point right here. And I know this point is actually going to land right there on that point once it's moved. So that's helping me out a little bit. I've moved this point over to this point. Okay. Well, let's put it just in purple now that you see it. Okay, so that's going to be my new graph. All right, back up 1. It's this one. It needs to go over 1, 2 of the purple marks. There, that looks pretty good. And we can move this guy, and he's going to land back on here. Now, I know this is going to be a bit of a stretch because we've got this kind of going up like this. That goes down. What happens after? We know we go back down. And so if it's a wave, so you can kind of like, won't it kind of get back up where it's, yes, it will. So if we've moved those, it's kind of interesting how you can see when you move the 1, 2, the points, you can also move this one, 1, 2 back, 1, 2. It's kind of like graphing a line. So it'll come back down over here and then come back up over here. Now, you can also use Desmos to graph that to verify that everything is correct. I would choose some peaks like this one, the crest here, possibly the 4 pi 6. Remember that that is going to be 2 pi thirds, that you need to be able to go back and forth, and that it starts there at the 0. So that'd be more than enough to be able to have some checkpoints. Here's a negative sine. Oh no, I can't do negative sine. Sure you can. Our amplitude is going to be a -2. Our period is 2 pi divided by 2, which is going to be pi. Our vertical shift, well, we're moving it on down 3, -3. And so we'll even write down 3. That'll help us out a little bit. Right or left movements? None whatsoever. Gotta love those. All right, so if we can get that parent function, we're done. Yeah. Let's go. Okay, here's my pi. Here's 1, 2, 3, 1, 2, 3, 1, 2, 3, done. This is pi halves. Okay. I need to split a half in half. Well, that's a quarter of a pizza, Miss Womack. I've done that many a times. So this is 1 pi fourths, 2 pi fourths. This is 3 pi fourths. Now, you can, again, we're going to invert that. The parent function and the mirrored function will start at 0, 0. Instead of going to +2, we're going to go to -2. Yay, which is messing with my pi fourths right there. So that's definitely a point, though, that we can check on the graph. And then we're going to come back to the line. We're going to go to the other side and then come back down like this. So it should look a little bit like kind of like that. Now, don't forget to stop into Desmos and check some of these graphs. Womack, out.